Hello, my dear students. I am Sanjay Misra of your maths teacher is going to discuss with you some problems from chapter 1 real numbers. Those are very important to the point of view of board exams. Okay? So now let us discuss. Our first topic is this: to express SCF of two numbers small a and b in the form of d is equal to xa plus yb. This is also called linear combination. Is that clear? Now, based on this, find the SCF of two numbers 81 and 237 and express it as a linear combination. Since it is given, integers 81 and 237 are such that where 81 is smaller than 237. Applying Euclid's division lemma to given numbers. 237 is divisible by 81 two times. So 237 is equal to 81 into 2 plus 75, where 75 is the remainder. That is not equal to 0. So now we have to take 81 as the dividend, 75 as the divisor. Now 81 is equal to 75 into 1 plus 6. Again the remainder 6 is not equal to 0. So dividend is 75 and divisor is now 6. 75 is equal to 6 into 12 plus 3. Okay. Now the remainder is 3. So that is not equal to 0. Now when we again divide 6 by 3, it is divisible by 2 times. So now remainder is 0. At this stage, so the last divisor is 3. Will be the required SCF of both the given number 81 and 237. Got it? Now the second part of this problem. To express the given numbers as a linear combination, we start from the last but successively eliminate the previous remainders as follows from equation 3rd. Where is the equation 3rd? This is the equation 3rd. So the remainder is 3. So now 3 is equal to 75 minus 6 into 12. We can write it like this from equation 2nd. Okay, from equation 3rd. Now again from equation 2nd, 3 is equal to 75. Put the value of 6 from equation 2nd. 6 is equal to 61 minus 75 into 1 from this. Okay. Now again 73 is equal to 75 minus multiplied by 12. 12 into 81 plus 12 into 75. 3 is equal to 13 into 75 minus 12 into 81. Got it? Now 3 is equal to 13 into 237 minus 81 into 2 minus 12 into 81. In this expression, we have to put the value of remainder 75 from equation 1. Where is the equation 1? This is the equation 1. So we put the value of remainder 75 from here. Got it? Now 3 is equal to 13 into 237 minus 18 into 26 minus 12 into 81. Now both are of minus sign, so we have to add them. So this is as it is. 3 is equal to 13 into 237 minus 26 and minus 12 is equal to minus 38 and 81 is common there. So we can write them like this. It becomes equation 5. Now this is the linear equation or linear combination for the given numbers like this. 3 is equal to 237x plus 81y, where the coefficient of 237 is 13, so the value of x is 13, and the coefficient of 81 is 38 minus 38, so the value of y will be minus 38. Hence we can find the values of x and y. Got it? And this is equal to the standard form of linear combination, where D is the SCF is equal to ax plus by, where a and b both are the given numbers. So the value of D is 3 because SCF is 3. Okay. So this is the complete or compact solution for this type of problem. Okay. Now, second important problem. Now our second problem is from Euclid's division lemma of this chapter. From Euclid's division lemma, to show that q of any positive integer is either the form of 9m or 9m plus 1 or 9m plus 8 for some integer m. Now solution part. Let a be any positive integer. Then it follows Euclid's division lemma. A is equal to bq plus r, where r is greater than or equal to 0 but less than b. Where a is equal to 3q plus r. When we compare it by this lemma, then the value of b is 3 and the remainder r is equal to 0, 1 and 2. So there are 3 possible cases. Got it? Now, then it is of the form 3 cubed or 3q plus 1 or 3q plus 2. Case 1. When the remainder r is 0, then a is equal to 3q. In this case, we have a cube is equal to cube of 3q is equal to 27q cube. When we make it the multiple of 9 like this, 9 into 3q cube, where m is equal to 3q cube, then we get it in the form 9m. Got it? Now case second, where the remainder r is equal to 1, then a is equal to 3q plus 1. Got it? Now a cube is equal to 3 whole cube of 3q plus 1. When we apply the formula of whole cube, then we get 27q cube of 1 plus 3 times of 3q into 1 inside the bracket 3q plus 1. A cube is equal to 27q cube plus 1, 27, 3 3s are 9, 3s are 27, q into q square, 3 3s are 9 cube. Got it? Now we arrange it in the standard form. So we get 27q cube plus 27q square plus 9q plus 1. It implies that a cube is equal to, here 9 cube is common in the whole expression. So 9 cube inside the bracket we get 3q square plus 3q plus 1 plus 1. It remains as it is. Now we put in place of q 3q square plus 3q plus 1 m. So m is equal to q 3q square plus 3q plus 1. Then we get the value of this expression in the form 9m plus 1. Got it? Now our second case, third case after this second case. Case third, where the remainder r is equal to 2. A is equal to 3q plus 2. A cube is equal to cube of 3q plus 2. Now apply the identity of whole cube. We get cube of 3q, cube of 2 plus 3 times 3q into 2 inside the bracket 3q plus 2. Got it? It implies that 27q cube plus cube of 2 is 8 plus 3 3s are 9, 2s are 18, 3s are 54, q into q square, 3 3s are 9, 2s are 18, 2s are 36, q is equal to, now arrange it in its standard form, then we get 27q cube, 54q square plus 36q plus 8. Okay, now 9q is common, equal to 9m plus 8, where the value of m we can put q inside the bracket 3q square plus 6q plus 4. Therefore, a cube will either be of the form 9m or 9m plus 1 or 9m plus 8. Okay, so these were some important problems from this chapter. Okay, if you have any doubt, you can discuss me. Got it? Okay.